Okay, so we skipped 1.5 if you're wondering, and we went to 1.6. All right, so let's talk about this. It says solving inequalities. Let's go over briefly some of the inequality symbols. Inequality. I'm sure you've seen these before many, many times. This should be review, but we're going to do it again. So if you have a little thing like this and it's pointing to the left, that means less than. All right, this is less than. If it goes this direction, that would be greater than. That's greater than. All right, again, these are inequalities, which means they are not equal. Okay, so it's not an equals. It would be that. What would that mean? Not equal to. That's right. Okay, so that just means that they're not equal to. All right, and then you got a variation of these right here. What do you think that is? What if I put a little line underneath of there? What would that be? Well, it would be less than or equals, what we would say. Now you could write it again. I'm just being lazy and just putting it right here. Okay, and then this is greater than or equal, so this would be greater than or equal. So you do have some possibilities of things that could be equal, right? But most of them are all inequalities. There's a couple properties. You don't really need to know them to be able to do these problems, so I'm just going to skip that because we started late today. So let's just go to this. Let's talk about graphing the inequalities first before we solve for them, okay? So graphing an inequality, yes. That's enough? Okay. Graphing an inequality. All right, so what if I asked you to graph x is greater than 5? Because you will have to graph a lot of these. A lot of these you're going to actually solve them, but then graph them. So we'll do the graphing first, and then we'll do the solving next. So if I said to graph x is greater than 5, well, you just make a little number line. This is only x, so it's not going in the x and y direction, so it's not a rectangular coordinate or a Cartesian coordinate. It's just horizontal, all right? And then you put some numbers in. If it's greater than 5, here's how I would do it. A lot of people always put 0 in the middle, then they put a bunch of negatives, then they put a bunch of positives. But I look to see the inequality. If it says it's greater than 5, then what I usually do is this. I usually put one number either to the left or the right. So if it's going greater than, I'm going to put a few numbers here. It's probably more than I need, but that's good enough. Okay. Now, if it says greater than, do you remember what we do? It doesn't say or equal to. It just says greater than. So can x equal 5 in this situation? No, it cannot. So I don't put a dot here or a closed circle. What do I put? Let's put this in a different color. Yeah, I put an open circle. Open circle. And then it says greater than. Which direction is greater than 5? Right. Everything to the right. That's why I put more numbers to the right. Everybody see that? Since I'm going to the right, I just put one number to the left. You could just put the 5 all the way to the left. It's perfectly fine. You could have put a 0, some negatives, some positives, but you're just kind of wasting your time. I think this is a good way to graph this. And then you just kind of shade in everything. I'll just make this a little fatter. Shade it in to the right, okay? Some people will do this. They'll go up and over like that. I mean, that's okay. I've seen that before. I would rather you just kind of shade it in, make it like a darker, thicker line so you can see it for sure. Definitely make sure that I see which direction it's going. Put an arrow there, and you're good to go. You've done that a million times, haven't you? Well, maybe a million's a stretch, but you've done it a lot. All right? So that's how we would graph an inequality. What if it said, I'll tell you what, we'll do this in a different color. What if it said x is greater than or equal? Then what would you do? Shade in the circle, that's right. So open means it does not include 5, but it includes everything just to the right of 5. But if it's or equal to, then what do? Now we shade it in, and then you go like that. That's the difference. Everybody good? Yeah, pretty easy. Later on, I don't know if it's in this book or pre-calc, instead of a open or a closed circle, they would use a bracket. Okay, and then instead of an open circle, what do you think they use? A parentheses going in that direction. All right. That's what you're going to see. The higher up in math you go, you're going to see more of that, the bracket and the parentheses, than the closed and open circle. Closed and open circle still kind of, I hate to say lower level. It's not really lower level, but kind of high schoolish. You know, when you get up into college and stuff and upper level math, they're going to use brackets and parentheses. I don't know why. They just do. All right, so we just be aware of it. I don't know if they're going to do that in this book or not. Maybe they will. I have a feeling they will eventually. We'll get away from the open circle, closed circle, and we'll go to the bracket and parentheses. I just can't remember off the top of my head. All right, enough of that. Everybody's okay with that, right? Yeah. All right. Let's start talking about how to solve an inequality. So, I got a bunch of stuff written down. I'm just going to make this as simple as I can. So, when you're adding or subtracting, so add and subtract. So when you're going to add or subtract something, for instance, we'll start off really easy. Okay, what if we had that? If you have addition, if you are adding something to x or subtracting something from x, this inequality stays exactly the same. So you wouldn't do anything different as if it was a equal sign. Okay, if that was an equal sign right there, you would know how to solve for x, wouldn't you? What would you do to solve for x if that was an equal sign? You just subtract 2 from both sides, right? And then you bring everything down. So in this case, if you add or subtract, that sign just stays exactly the same. We don't do anything with it. We don't mess with it. So it's still greater than what? 7 minus 2? 5. And again, they're going to ask you to graph it. We just graphed it a minute ago, but they will ask you to graph it. So addition and subtraction, you are not going to change the inequality, right? Now, for multiplication and division, so for instance, let me give you this. What if I said x over 3 is greater than 4? Again, pretend that that was an equal sign, all right? Just a regular equation. How would I get x by itself? What would I have to do to that 3 to get rid of it? I multiply. Why? Because I'm dividing it, right? It's x divided by 3. How do you get rid of something that's divided by? You multiply. Now, as long as you multiply and divide by a positive number, you don't change the sign. Everybody hear me? So if you multiply or divide by a positive number, you don't change the sign. So you work with it just like it was an equal sign. So how do I get rid of this? Multiply by 3, cancels. X, what do we do with this? Just keep it greater than, right? And then 12. X is greater than 12 is your answer. You graph it, and you're good to go. Question? It would be the same thing. If it was or equal, this would stay or equal. That's not, we're not doing that. We're just doing greater than or less than. Okay? Now, what if we do this? Here's the one where you're going to have to change something. This was multiplying and dividing by a what? By a positive. So what do you think multiply or divide by, I'll put the word in here instead of just writing the sign, by a negative. If you multiply or divide by a negative, that's when you change the sign. So we'll keep it positive. So what if you had this? How would you get rid of this negative 2? Divide by what? Negative 2. Now, look what we just did. We divided by a negative. So if you multiply or divide by a negative, then what do you think you're going to do to this sign? You're going to change it. That's right. Make it go the other way. So this was greater than. What are we going to do? We're going to say x is what? Less than. And then you just do the work, negative 5. Let's think about that for a second. Let's put both of them down, but let's make this positive. What would you do here? This is all positive. Divide by 2, divide by 2. So this would be what? X is greater than what? 5. Everybody see that? But this one, we changed it. Let's see if it really works. Remember what we're putting it into? This original inequality right there? So pick a number, not a crazy big number. Pick a nice little number that's bigger than 5. 8? Okay, let's put an 8 in here. So 2 times 8 is what? 16. Is 16 greater than 10? Yes, it is. You can pick any number that's bigger than 5. Pick 6. All right? 2 times 6 is 12. Is 12 bigger than 10? Yes, it is. All right, so that works. Would you agree? Let's do this. Now this one, when we change the inequality, let's see if it works. Now we have to pick a number that's less than what? -5, and see if this works. So again, what are we putting it into? We're putting it into this original inequality. So check it out. Give me a simple little number, the smallest number you can. -6 is a good one to put in here, okay? So what's -2 times -6? It's positive 12, isn't it? Is positive 12 greater than 10? Yes, it is. Let's pick a number that's not. Let's say we forgot to change it and we said x is greater than -5. Now this is incorrect, all right? But let's say we did that. We forgot to change it. So give me a number that's bigger than -5. Easy number, bigger than -5. 2. Let's put a 2 in for this. -2 times 2 is -4. Is -4 greater than 10? No, it's not. So is this correct? No, it's not. So that's why you change the inequality. Everybody see that? So that makes it work. All right? So when you multiply and divide by a negative number, that's when you change the direction, change the sign, the direction of the inequality. That's probably the best way to say it. We good with that? All right, let's do a problem. Let's graph it. This is the kind of stuff you're going to see on the homework, you're going to see on a quiz or test. So this is example 1. And it says solve. Here we go. 4x plus 12 is less than 8. And you want to graph it. Solve and graph. Well, let's solve it first before we graph it. It's just like any old Algebra 1 problem, all right? With one exception, one possible exception, I should say, is if you multiply or divide by a negative number, all right? What about adding or subtracting? If I subtract, it's still fine. You keep the sign what it was, all right? So let's do it. So negative -12 minus 12, 4x. Do I change the inequality? No, because all I did was subtract. Okay, I don't change the inequality if I subtract. So keep it the same direction. And what's that? -4. Divide both sides by 4. Now I did divide, but I divided by a positive number, correct? So do I change the inequality? No, I don't. So x, it's still less than what? -1. It's really basic Algebra 1 stuff. Would you agree? Except if you're multiplying or dividing by a negative. That's the only time where you got to change something. Every other time is perfectly fine. But when you multiply or divide by a negative, that's when you change it. We didn't do that here, so look, it stayed less than, less than, less than. We didn't have to change it. So that's my answer. And now I want to graph it. So let's graph it. It's going to be less than -1, so I'm going to go put a -1 here, put a 0 there. You don't have to do it exactly like this, but this is the way I like to do it. All right, you put enough numbers in here, but I don't have like too many, right? You don't want to like put 20 numbers in there. It's just a waste of time. It's less than -1, so is it going to be an open or closed circle? It's going to be open because it's just less than, and then we shade everything in which direction? To the left. It's less than, so oops, we shade everything here, and that's what it's going to look like. Make sense? Yeah, pretty easy. Let's do another one. It's really not much different. It's just the algebra is a little bit more involved. That's the only thing different with this. Everybody got this part? Can I scooch it up? Yeah? I'll take your silence as a yes. All right, example 2. Oops, let's change this back to white. Example 2. All right, same kind of deal. It's just a little bit more algebra to do. All right, we're going to solve this, and then we're going to graph it, okay? Just didn't write that down here. So let's go through it real quick since I'm running out of time here. Multiply 2, so we distribute that, so that's 2x plus 18. Distribute the negative 6, so it's a negative 6x minus 12. Make sure you do that. It's a common mistake students forget. Greater than or equal to x minus 4. I haven't even moved anything from one side to the other yet, so I don't even have to worry about changing my inequality. Even in the next step, I don't have to change it. All I got to do is just add some like terms. 2x minus 6x is negative 4x, plus 18 minus 12 is plus 6, positive 6. Again, I still didn't even move anything over, so I just keep that greater than or equal to x minus 4. Now, we want the x's on the same side, so let's put it on the left-hand side. So let's take this minus x to get rid of it here, and put a minus x here. We'll take the number 6, the positive 6, and move it to the other side, so we subtract a 6 from both sides. That cancels. This is negative 5x. Now, did we just subtracted here? Do I change the inequality? No, not for subtraction. And then what happens here? That canceled out, and I'm left with negative 10. Now watch this. I divide by what? What do I divide by? I got to get x by itself. Nobody's talking to me today? What do I divide by to get x by itself? Say it, no. Negative 5, good. So divide by negative 5, divide that by negative 5. Now what did I just do? I divided by a negative 5. So what does that tell me to do? I switch the inequality, that's right. Change the direction of the inequality. So that cancels out, I got an x. Now I got to go less than or equal to, all right? And this would be what? Negative over a negative is positive 2. That is what we should get. Now we graph it. And it's less than 2, so let's put a 3 here, a 2, 1, 0, negative 1. Okay, so 2, 1, 0, negative 1, negative 2. All right, so this should be the easy part. Less than or equal to. If it's or equal to, what kind of a circle do we put here? Close, very good. So we close in our circle, and then it's less than or equal to, so it's everything shaded to the left, and that's how we would graph it. So you need both of those things in order to get this problem right. Had somebody in my pre-calc class, every single problem was graphing. It said graph, 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 graph. All they did was just solve. They didn't graph. And I took like 3 points off the homework because they didn't do what they were supposed to, every single problem. So make sure when it says to graph that you graph it. All right, a couple more and we'll be done. Yeah, this example, the math is the same. It's just the answer that you get at the end is a little bit different. It's not exactly like what we just finished with. So example 3, here we go. Again, it says solve and graph. Now sometimes weird things happen with your answers, and these are 2 examples where a weird thing happens. Let's do it. Let's distribute. Negative 6x plus 27 less than negative 6x minus 8. Add an x to both sides. 6x, sorry. Add a 6x to both sides. Do you see what weird thing happens right now? Your x goes away, doesn't it? All right, well, let's still keep going. So bring this down. So that says 27 less than negative 8. Look, I don't have any variables. My variables canceled out. So that was kind of weird. But what's really weird is this. look what I'm left with. It says 27 is less than negative 8. Is that true? Is 27 less than negative 8? No, that's not true. Would you agree? So not true. So we say, when you come out with this and you get an untrue statement right there, we say that there's no solution. There is no x that exists in the world that makes this left side less than this right side. You can pick any number you want, and you're not going to find one that makes this left side less than the right side. Okay? That's no solution. That's my answer. That's what you would circle right there. One more and we'll be done. Same kind of thing. Again, weird answer, but the answer we get is different than no solution. Minus 15x greater than or equal to 0. Let's do the math real quick. 15x plus 30 minus 15x greater than or equal to 0. 15x minus 15x is what? 0. And what are we left with? 30. Now look at this one though. Is 30 greater than or equal to 0? It's not? Or. It doesn't say and, it says or. Greater than or equal to. Yes, it is greater than. And you're right, it's not equal to 0, that's true. But the key word is or. So yes, 30 is greater than or equal to 0. So this is true. So what's the difference? The difference is every single number that I pick for x will work with this inequality. I can pick any number in the world, put it in for this x, put it in for this x, and this left side will be greater than or equal to 2. So my answer is this. It's all the real numbers. That means every single number works. Wait, let me write this down first. All right, so it's section 1.6, and it's page 32, and it's 9 to 26. Remember, on the lesson plan, I accidentally wrote 16. It's supposed to be 26. So there it is right there, 26.